Okay, we've been asked to differentiate this function that's determined by a function in terms of x in terms of t and y in terms of t. So we want to find, the main goal is to find the gradient, but basically that means we need to find a gradient function. That means we do need to differentiate. Okay, so the first step is to differentiate with respect to x, because the gradient is going to be dy dx. Okay, so we know that is actually the gradient function at any point, but we want the gradient function. Now the only way we're going to get that is by using the chain rule. So if we differentiate dy with respect to t, and then we differentiate t with respect to t with respect to x, we will have those two dt's cancelling, and we'll be left with dy dx. So we've already been given y equals t squared minus 4t, and if I differentiate that, dy with respect to t is 2t minus 4. Okay, x we've been told is equal to 4e to the 0.5t. So if I do dx dt, 0.5 times 4 gives me 2 e to the 0.5t. Okay. Now the main goal is to do dy dt times dt dx. We've got dy dt, okay, that's 2t minus 4. And we want to times that by dt dx, and that's times in by 1 over 2e to the 0.5t. Okay. The reason we're doing 1 divided by 2e to the 0.5t, 2e to the 0.5t is dx dt, we want dt dx, so we're just going to do 1 divided by dx dt. Okay. Now we want to actually be able to finish this problem up. Okay. We want the gradient when they've asked us when the gradient is to the tangent when t equals 6. So we actually want, we've got the gradient. Okay, the gradient is going to be what the gradient function is when t equals 6. Now this is the gradient function, we've just worked it out. Okay, so what happens when t equals 6? Well, I have 2 times 6 minus 4 times 1 over 2 e to the 0.5 times 6, which is 3. Okay, so then if we have we're literally just going to put that into our calculator, so putting in your calculator 2 times 6 minus 4 with the brackets around it times 1 over 2e to the power of 3. That ends up being 0.199. Okay, so that's it has a few more decimal places, but we'll just round it off to 3 significant figures. Okay, so just going over the whole method of how we did this problem. Oh, that's a little bit unusual. The answer is just going to sit there apparently. We used dy dt over dt dx to find the gradient function. Once we had the gradient function, we found what the gradient was when t equals 6. And we're putting t equals 6 into the equation, and we end up coming out with that 0.199, which is the thing that seems to be floating around regardless of where I move this screen. Okay, so the overall method, if you ever want a gradient, okay, they're asking you find the gradient of the tangent. Gradient of the tangent at t equals 6. That means we're going to be using t equals 6. We're going to be using dy dt times dt dx so that we can have the gradient function. We've got the gradient function, we can substitute t equals 6 into it to find what the gradient is.